Okay, vector valued functions. Okay. So we have parametric equations, and then we have a vector valued function. So basically, it's a function defined by vectors. Yes.
Just curious, why did they pick such similar letters as I and J for that way of writing vectors? Couldn't they do something like I and K?
K is the third variable when we talk about this in 3-space. Which you will notice when I give you homework problems tonight, there are some functions that have I, J, and K. K would be like the Z in 3-space.
What about I and E? Yeah, they're just so similar. You know?
I think that's why they chose them.
That's annoying.
X and Y are similar.
It also could be a Latin thing. I don't know what words are in Latin. I don't know Latin, but you know, that was.
Okay, got it.
Okay. So basically, these functions are drawn using vectors, as you can see in the picture.
Oh, there's like, yeah.
So basically, instead of having like two different equations for our parametric equations, we have one function defined with vectors that's basically doing the same thing as a set of parametric equations would be doing. Does that make sense? That P of T would be the name of the vector value function. Okay. So if we have parametric equations, x equals cosine of t, y equals sine of t, then our vector value function would be cosine t I plus sine t j. Okay, it's just we can write it as one equation. But the vectors are telling us where to go. Okay, so what would P of 0 be?
1, square. We'll fix that problem. I think
So
nailed the top.
we're right here. What about P of pi over 2?
J.
We don't know that.
P of 5.
Negative I. So it's like I u. Then we can use that this is J cubed.
Okay, now this is still
Arrow.
defined parametrically. Okay, we still need our direction. What?
We can't answer that
just
question. Or can we answer that?
Talking about the quiz could be considered cheating.
Okay.
Okay. Your hair looks nice, by the way.
Oh, thank you.
You like that?
had serious cavity hair the other day.
Is that what it's called?
Yes.
Brilliant.
Okay.
Oh.
Okay. When we talk about the domain of a vector value function, we have to consider the domain of each component. What is the domain of the horizontal component?
Everywhere.
What is the domain of the vertical component?
Wait,
Oh.
I thought that was the random y, and I thought you were trying to show us that that's the y equation.
Nope, sorry, that's the 1/2. I
Okay.
wanted to do 1/2.
I thought it was a random y too.
So now, what's our domain of R?
0 to positive infinity.
Where do they overlap?
0 to positive infinity.
Yes.
There wasn't another question.
Oh,
It could be both.
phrase it like a question.
She did say where.
She said, where do they overlap?
Did she phrase it like a question?
Yeah.
That was
See?
I didn't really hear the inflection.
Don't like when British people talk, don't they kind of have an inflection after it?
that's Australian.
Oh, excuse me.
Well,
What?
It's not British
I
here?
mean, it would say sounds like a question.
Oh, upspeak.
No.
That's what you're thinking of.
That's what I was doing.
There was a person on Jeopardy the other day with some pretty seriously awful upspeak.
Well, then they always say one is those.
Okay. We are going to graph this guy. What's its domain?
Negative infinity to positive.
Okay, all real numbers. Okay, when you graph these, you can draw out all the vectors, or you can go back to our parametric knowledge and eliminate a parameter. Okay, what would you like to do?
Eliminate the parameter.
Okay, so we know that our horizontal component is 2 cosine of t, and our vertical component is sine of t.
You do the square thing.
What's the square thing?
Cut sine squared plus sine squared plus 1.
And what would cosine squared be the same as? Okay,
Plus y squared over 1.
so what do we have?
You need that.
In the list, we're horizontally, we're going to move from the center.
2, 1.
What?
2, 1. Wait, oh, sorry.
2.
2.
And vertically?
1.
And how do we know our direction?
Yes.
0.
You can plug in some.
What?
Counterclockwise, do you agree?
Yep.
0 would give us a vector 2 or 2i.
Yep.
Pi over 2 would give us the vector j.
Yep.
Excellent.
Excellent review.
No.
Wait, what happened?
I can't spell with it like that.
What are we doing?
Try to spell excellent.
Just draw a smiley face.
EXCELENT.
With that X, it threw me off. I thought I was spelling it wrong. Excellent. That's what I was trying to spell.
So you should make it like build up.
You should change it to logic.
Okay. Limit of a vector value function. Basically, you can take the limit of each individual piece.
Hope you guys aren't gonna get an accident from this
No,
snow day
yeah.
because we're going to the hospital anyways.
Well, wouldn't you
Didn't we get out early?
you would need time to get in?
No, monarchs did not get out early. Don't believe everything that you hear. Why would the monarchs get out early and us not? That makes no
Well,
sense.
I told you
It
I
is a
get
rumor.
started late, so now they're getting out early too.
No, we did not start.
They couldn't
Sean got
go
out
to
early,
school
Sean got
today.
out at 2:22, he came here.
Yeah.
Thanks, Sean.
You're starting rumors. I started.
Come on, Sean.
Did Sean start today?
Yeah, apparently.
Good work, Sean.
Wait, logistic functions? Because rumors.
Vice minus
Sean's like,
Hey, we're gonna take this limit.
Kind of weird.
Write it down.
It's hospital.
I think we're gonna have to. Yeah.
Get a little ambulance up.
So first of all, we can take the horizontal component. What's the limit as t approaches 0 of e to the t?
1.
So we have 1i. Plus, what's the limit as t approaches 0 of sine of t over t?
1.
So we have 1 times j. If you remember anything from calculus 1, you wouldn't even need the hospital's rule,
A gram,
Sure.
right?
Yeah.
but you could.
why I like that.
Yeah.
Why are you arguing over?
Well,
It makes
how-
things easy because it just includes.
Why do we not need law?
Because the limit as t approaches 0 of sine of t over t is one of those special limits that we talked about.
Okay, cool. Thank you.
But the more we learn, the
Well, now we know why it equals 0.
right now we have L'Hopital's rule to make that easier, and so that if you forget, you have something to fall back on, right? Okay. Continuity of a vector value function. Continuity.
Oh, I did it.
Derivatives.
Integral.
We don't need derivatives to talk about continuity. But to be differentiable, we need it to be continuous. That I agree with.
That's what it's going.
Okay, let's talk about continuity. Okay, so we're going to call our function R. If R is continuous at points at t equals a, what has to be true?
Both of the other functions are.
The limit has,
Oh,
the limit, the both sides limit have to be the same.
So first of all, the limit as t approaches a of r of t
Exists.
needs to exist.
And then R of T exists.
Or
R
what?
of A. And limit of as T approaches A of R of T equals R of A. I'm guessing. And there's going to be one other special one because this is
No.
not okay, never mind. So it's literally just the same as before?
It is, but we have to consider both pieces of our
Yeah.
function.
Components.
Components would be the word I really want to talk about.
Like vertical and horizontal.
Why not
Why not what?
diagonal?
Diagonal.
Diagonal perpendicular.
What?
Nothing.
If our axes are aligned likewise like and towards negative axes, then yes, it would be.
Well, then it wouldn't really matter because the reference point would just shift to, and you wouldn't be able to tell the difference.
What point are we trying to find?
I want to know where this is continuous.
Oh.
I believe this is continuous to point 1 to
Oh, well, we need a value.
One to infinity?
Yeah, that's my domain.
Inclusive on the left side,
Yeah.
where their domains exist.
Okay, their domains overlap at including 1 to infinity. So that would be the domain. Are we continuous along all of that?
Yeah, both of those are smooth curves.
Yes.
Well, that wouldn't affect continuity.
It doesn't have any holes.
There's no holes or asymptotes.
Because there's no denominator.
They're not
Yeah.
zero at the same
True.
That
No, that's the
wouldn't matter.
derivative.
Yeah, you guys are really focused on derivatives right now.
Sorry.
You do need to be continuous in order to be differentiable, but you can be continuous and not differentiable. Like there. Why not say them? Right?
They don't
Make
fly
like
so
that.
well.
No, I see it. That's
They don't fly so well upside down.
Didn't you
Yeah.
used to make birds like that, Andrew?
Yeah, I missed why we're drawing that though. Oh, we're talking about that one weird
It's
one.
gonna be upside down.
No. Well, I was talking about this is continuous but not differentiable.
Right, right.
You made it work.
I just drew way
Why is
too
the
many
bird
birds.
upside down? That looked like a right side up bird.
The first one was a wave.
Oh, okay. This is
First
for
one was
Third definition.
Ew.
Hey, derivative.
Is this getting recorded for Mary Ann?
Mm-hmm.
Okay.
And
Um,
I'm screwed up.
Kevin!
So many of my other
okay. So up here, you notice that this is the definition of a derivative. So let's figure out what the derivative of R of t is. Okay? So I'm going to define R of t to be f of ti plus g of t. Okay? We're going to figure out the okay? R of t plus h.
F of t plus h plus g of t plus h.
Minus
G and J.
R of t.
Distance.
Okay? So this is what I'm going to do. I'm going to break this up into two different limits. The limit, as h approaches 0, I'm going to take f of t plus hi minus f of ti over h. And I'm going to add it to the fraction g of t plus hj minus g of t j over h. What can we conclude?
that is the derivative of I plus the derivative of
How many of you are just going to assume that anyway?
all of us.
Alright? Okay, but now we proved it, so
Wait,
yippee-doo.
prove the limit definition first.
Divide it.
I plus
Okay.
2J
Minus 2TJ.
minus 2TJ.
Well, let's let people write it down.
You don't even know if she wants us to take the derivative.
Yeah, he probably isn't even driven.
No, I just told everybody to drive it and you all
Please excuse this interruption. There has been a bus change this evening.
started. Because the bus crashed.
Bus 03A will be bus 09A. Again, bus 03A will be 09A. Thank you.
On the side of the bus, so like, I'm gonna be a zero.
Okay. What is the domain of RFT? All real numbers. Where is it continuous?
Everywhere.
Everywhere. Okay. What is the derivative?
I minus 2pj.
Okay. So let's see. What does this look like?
Derivative? Is that what you're asking?
Let's talk about RT.
Oh, RT,
There's a crap. Well, if x equals t, and y equals 4 minus t squared, and y equals 4 minus x squared.
Well, that one's pretty easy.
Okay, what would our direction be? Where would our arrows go?
To the right.
Like this?
Yep.
Okay. So let's talk about our derivative. What is r prime of 1?
4, or no.
I minus 2j.
Then we have a tangent vector here at 1, 3, 1. There's our tangent vector. What would, okay, so this is, what would a normal vector be?
The normal vector would be
2ij.
No, 2j plus I.
Yeah.
Minus j.
2 I plus j?
Yep.
Or?
Or 2j minus I. Or no.
Negative
No,
2i plus
I
j.
minus,
Or minus
negative
j.
I minus 2j.
Okay, so normal, we would have the vectors, you told me 2, 1, or negative 2, negative 1. Because if you think about like the slopes, they would be opposite reciprocal of the rise over run for your tangent vector.
Basically, you just switch the constants and the signs.
One sign.
Oh, one.
All right. Let's go back to our smoothness.
Eric is smooth. That prime of t does not equal g.
Okay, so how else can we write that? We can write everywhere except when r prime of t is 0, because that would mean the 0 vector means 0 for horizontal, 0 for
Vertical.
vertical. Okay?
Anti-horizontal.
What?
Why did we switch to R notation somewhere here? Like, we're using P from the beginning and now we're at R.
Those are the two common ones you're going to see.
same question, but I thought I was just gonna look stupid again.
Remember, that word's not allowed in my classroom. And it's just the two different ways that you're gonna see it written, okay? So, I want to know if this is smooth. So what should we do?
One plus cosine Ti, or theta. Plus sine T.
Always.
Because they're bolded. That's to tell you, like, the vector I. And really R is bolded too. Okay. All right. So where is 1 plus cosine? What?
What?
Because this would mean cosine is negative 1.
So pi. Or 3 pi, or 5 pi. Basically odd number pi.
So
Okay.
the place, wait, no, I'm not, I was looking at your thing.
Okay. Where is sine equal to 0?
0, 2 pi.
Basically, we're both. Right?
Basically, we're not bolded.
Wait.
Basically wherever
Oh,
n equals odd number pi.
So I'm not smooth when t equals.
N pi and
oh, yeah, okay, now I get it. Wait.
No.
Pi plus
Oh,
2
yeah,
pi.
yeah, yeah, that one. Okay.
Where n is in the integer. Okay. Okay. We have one thing left to talk about. What is it?
Derivatives of
Integral.
Optimization. Standard.
Logistical. Stop it.
Okay, so just like we take the derivative of each with respect to t, when we integrate r of t, we're going to integrate each component separately with respect to t.
Use F and G instead of X and Y.
Yes. And this is what we're going to integrate. Don't get ahead of me, just write it down.
wait, really percent.
Yeah.
That's why I said don't get ahead of me.
Well, they're just constant.
It's Christmas, we'll use red and green.
Christmas colors.
When we take, okay, so we're going to do each of these separately, okay? So, we're going to do this, right? Antiderivative. E to the t,
Plus C.
and I'm going to label it C1, plus native cosine plus another constant, j. So basically what we have is we have e to the t I minus cosine of t j, and then we have plus c1i plus c2j. So what we can do is we can just call this a constant vector.
CB. Constant subvector.
If you want to do that, that's fine. I just bolded my C. Okay? Or sometimes I make a little hat on them. that is why. You got me. We will do the fundamental of pyramid calculus tomorrow.
Again.
These,
Oh,
is,
Deja vu.
Are you going over that with your calc yet?
no, not till second semester.
Yeah, second. I thought we like covered it like we were like before first semester. We were just
No.
that good.
No, right before Christmas, you just talked about anti-derivatives and U substitution. That's it. Okay? Now, but we don't have time for U substitution because we have like 4 days less this semester than we did last year. So this is your homework. This really has no calculus in it. It's just working with vector valued functions. We'll finish up the calculus portion tomorrow and have a worksheet.
You mean VVF?
Yes. VVF, VVS.
Value means yes.